Indices, or powers, are a form of mathematical shorthand. In the same way that we can simplify 2 plus 2 plus 2 plus 2 into 2 times 4, indices allow us to simplify repeated multipliers into a single base and an index. Let's say we had this type of equation. Obviously, we can tell that the number 3 is being multiplied 5 times. Of course, we could multiply each number individually. However, that gets more difficult, especially when we are dealing with greater numbers. So therefore, it would be wise to convert this to index notation, which, in this case, would be 3 to the power of 5, to which the final answer can be produced on a calculator. Again, if we had a situation like this, it would make more sense to convert the numbers to index notations. Now, since there are 7 6s and 3 4s, we would just convert them to 6 to the power of 7 multiplied by 4 to the power of 3, making the final answer this. Now, in this topic, it would be wise to know basic power values by heart, such as powers of 2 and powers of 3. Here is a list of the basic ones you should know. Let's say we had a situation like this, and we wanted to find the final answer. As we already stated, we need to start by converting these numbers into index form, which would 3 to the power of 3 multiplied by 3 to the power of 7. However, if we were to remove the brackets, we would notice that we could also convert this equation to 3 to the power of 10, giving us the exact same answer as the previous index. What we notice, as a rule, is that any number, such as n, to the power of any a multiplied by n to the power of any b is equal to n to the power of a plus b. Only indices with the same base can be combined. For example, 2 to the power of 3 multiplied by 3 to the power of 4, multiplied by 2 to the power of 2 can be converted to 2 to the power of 3 plus 2, which is 5, multiplied by 3 to the power of 4, making our final answer 2,592. What about if we wanted to divide indices, such as 2 to the power of 9 divided by 2 to the power of 6? Well, firstly, we would need to convert this equation back to standard notation, which would look like this. If we were to divide the two numbers, we would effectively be canceling out any 2 in the numerator that corresponds to 1 in the denominator. In the end, that would leave us with no 2 in the denominator and 3 2's in the numerator. Converting this to index notation would give us 2 to the power of 3, which is simply 8. Again, what we notice is that when we divide indices with the same base, we are subtracting the powers from each other. So as a rule, n to the power of a divided by n to the power of b is n to the power of a minus b. Similarly, let's say we wanted to say 5 to the power of 0 divided by 5 to the power of 6. From the previous rule, we would just subtract the powers from each other, leaving us with 5 to the power of negative 6. As a power, it is pretty hard to quantify what a negative really means, so let's use a different law. A basic rule of powers is that any number that is to the power of 0 break down to 1, even if that number is itself 0. So 5 to the power of 0 becomes 1. Therefore, the equation changes to 1 divided by 5 to the power of 6, which will be 1 over 5 to the power of 6. What this shows us is that any negative power, like n to the power of negative a, is the reciprocal of n to the power of a. Finally, what if we wanted to equate an index into a square root? Well, take n to the power of a being equal to the square root of n. To remove the square root sign, we need to square both sides. That we will have open bracket n to the power of a, close bracket squared being equal to n. From our understanding of powers, the first expression is wanting us to multiply n to the power of a twice, so we need to add the two powers, giving us a plus a, or 2a. Now, we need to find out what a is as a number, and since the two expressions have the same base, we only need to solve the powers. If these two values are equal, then 2a must be equal to the power of n, which is 1, as any number to the power of 1 is that number. Therefore, if we divide both numbers by 2, we will get that a is equal to a half, which means that any number to the power of half is actually the square root of that number. In fact, We can even go further than this to ask what n to the power of 3 over 2 is. Now, since 3 over 2 as fraction is just a half times 3, we could write this in bracket form, and since we already know that this becomes a square root, we just need to cube this result, making it look like this. Therefore, as a rule, we can say that any number n to the power of any a over b is equal to the b root of n to the power of a. For example, if we were to evaluate 125 to the power of 2/3, that would the cube root of 125 to the power of 2. The cube of this would be 5. Then we square it, giving us 25 as our final answer.